Okay, so today I'm going to show you an easy way to do stoichiometry problems, which are one of the most challenging things we have to do in chemistry. And this will work for mass, volume, or mass-volume type stoichiometry problems. So there are 3 steps you can use to do these complicated stoichiometry problems, and they always work. The 3 steps are finding moles of known is step 1. Step 2 is finding moles of unknown, and step 3 is finding grams or liters of unknown. So presuming you're given a problem where you have grams of a quantity and you want to find grams of an unknown quantity of a product, you would simply convert the grams to moles of your known, which is what you were given, multiply times moles of unknown, that's your unknown quantity that you want to find, times the grams or the liters of your unknown quantity. So let me show you an example of how this works. Say we're given a problem where we have aluminum reacting with iron oxide to produce iron solid and aluminum oxide. And this is called the thermite reaction. Very spectacular demo. And we want to find out what is the mass of aluminum oxide product that is produced when 2.3 grams of aluminum reacts with iron 3 oxide. So the first thing I like to do is write down my given quantities, and that's my 2.3 grams of aluminum, that's my known, and I want to find the mass of aluminum oxide. So I'm going to put a big question mark grams here under the product. Okay, so I've identified my known, I've identified my unknown, and now I'm ready to plug in my 3 steps. Now the 3 steps again are finding moles of known, finding moles of unknown, and then finding grams or liters of unknown. So we're going to take 2.3 grams of aluminum and we're going to find moles of known. So I multiply times moles of known on top, that's aluminum, and what goes on bottom is the unit I want to cancel. Notice I'm putting in units, not numbers, because I want to make sure I get the numbers in the right place. Next, I'm going to multiply times moles of unknown. That's my step 2, which is my product. And on the bottom, I'm going to put moles of aluminum because that's what I'm going to cancel. And last, I'm going to multiply times grams of unknown. That's what I wanted to find. And on the denominator, I'm going to put my moles of aluminum oxide. Now comes time for the numbers. And the first thing I need to know is how many grams of aluminum per mole. And if I look on the periodic table, I can see that the molar mass of aluminum is 27 grams of aluminum per mole. And if I look at my balanced equation tells me that there is 1 mole of aluminum oxide per 2 moles of aluminum. So that's my molar ratio from the balanced equation. And now I have to look up my molar mass for aluminum oxide. And going to the periodic table again, I find that the molar mass for aluminum oxide is 102 grams per mole. Now my problem is essentially done. My moles of aluminum oxide cancel, my moles of aluminum cancel, and my grams of aluminum cancel. And when I crunch the numbers with my trusty calculator, I get 4.3 grams of aluminum oxide. There you have it. 3 simple steps to find, in this case, the grams of an unknown product, unknown quantity because we don't know how much we're going to get. Keeping in mind that our given known quantity is 2.3 grams of aluminum, assuming that there's an unlimited supply of iron 3 oxide for this reaction to take place, to finish. Okay, so that's a good example of a mass stoichiometry problem. Now let's try one that is a mass volume. So in this case, our 3rd step is we're going to find the liters of an unknown. So again, our 3 steps are finding moles of known, finding moles of unknown, and step 3, finding liters of unknown in this case. Here's our problem. We have sodium bicarbonate, which is it's going to decompose into sodium carbonate plus water plus carbon dioxide. And here's our problem. If a sample contains 4.0 grams of sodium bicarbonate, what volume of carbon dioxide gas is produced at STP? Okay, so I'm going to write down my given of my known, 4.0 grams. And I'm going to write down a big question mark under carbon dioxide product. And they want to know liters, which is my volume. And I know from past experience that the molar volume of any gas at STP is 22.4 liters per 1 mole at STP. So that equality will probably serve me well here. So we're going to start with our 3 steps, and I'm starting with grams. That's what we're given, 4.0 grams of sodium bicarbonate, or sodium hydrogen carbonate as it's sometimes called. Step 1 is finding moles of known. Step 2 is finding moles of unknown. In this case it's CO2. And step 3 is finding liters of unknown, which is my CO2. On the bottom, I'm going to cancel grams sodium bicarbonate. Down here I'm going to cancel moles of sodium bicarbonate. And down here I'm going to cancel moles of CO2. Going back to my molar volume is 22.4 liters per mole. That's my equality for my finding liters of CO2. My molar ratio from my equation is 1 mole of my equation is 1 mole of CO2 per 2 moles of sodium bicarbonate, and my molar mass for sodium bicarbonate is 84 grams per mole. Okay, and my moles of CO2 cancels, moles of CO2. My moles of sodium bicarbonate cancels, and my grams of sodium bicarbonate cancels, leaving us with liters of CO2. So I crunch my numbers with my calculator by multiplying 4.0 times 1 divided by 84 times 1 divided by 2 times 22.4, and I get 0.53 liters of CO2. So there you have it, 3 easy steps to find grams or liters of an unknown using stoichiometry.